Look at a world map. Now find Greenland. Big, isn't it? It looks almost as big as Africa, but here's the truth. Africa is 14 times larger than Greenland. This is just one example of how maps, while incredibly useful, can be deceptive. They flatten our round planet onto a flat surface, and this process inevitably leads to distortions. Why does this happen? Imagine trying to peel an orange and make its skin lie perfectly flat. It's impossible. You'll have to stretch some parts and tear others. Maps face the same problem when representing the Earth's curved surface. The Earth is a sphere. Well, almost. It's slightly squished at the poles. Maps, however, are flat. This fundamental difference creates a challenge for cartographers, the people who make maps. To create a flat representation of a round object, they use map projections. A map projection is like a set of mathematical rules that translates points from the Earth's surface onto a flat plane. Think of it like shining a light through the Earth onto a piece of paper. The shape of the light hitting the paper will be distorted depending on the position of the light and the paper. One of the most famous map projections is the Mercator projection. Created in 1569 by Gerardus Mercator, it was revolutionary for its time, particularly for navigation. The Mercator projection shows lines of longitude as parallel, making it easy for sailors to plot courses using a compass. However, this projection significantly distorts the size of land masses, especially near the poles. That's why Greenland looks so enormous on a Mercator map. While useful for navigation, it creates a skewed view of the world. Other projections, like the Gaulle-Peters projection, attempt to show land masses with more accurate relative sizes. Maps are powerful tools. They help us navigate, understand spatial relationships, and visualize data. But we must remember that every map is a representation, not a perfect replica of reality. Different projections serve different purposes, and understanding their strengths and weaknesses is crucial. When we look at a map, we should consider the projection used and its potential biases. By being aware of these distortions, we can develop a more accurate and informed view of our world. After all, the Earth is round, and squeezing it onto a flat surface will always require some compromises.